So hello students, myself Palashamurthy, assistant professor in the Department of Mathematics, Government Science College, Chitradurga. So this is the 13th session of line and multiple integrals in the topic numerical methods 1 and calculus 4. As in previous sessions, we discussed the triple integrations and its evaluation. So in this session, I am going to discuss the evaluation of triple integral by changing the variables. By changing the variables to some other variables, how we can evaluate the triple integrals. Yes, let us see. So change of variables in the triple integrations. Suppose the uh, this is the given triple integrals f of x y z over r into dx dy dz. So that can be evaluated by changing the variables x y z into some other variables like u v w. So then, in double integrations, we have to find the Jacobian for three variables. So that is Jacobian j is equal to del of xyz by del of uv w. So all of you know its expansion in the determinant form, and that j should not be is equal to 0. So then, this triple integration over r f of xyz dx dy dz is related to uvw such that which is equal to triple integration over d phi of uvw. So it is the function of uvw into Jacobian j into du dv dw. So here the variables x y z is vary in the region R, and the correspondingly uvw vary over the region D. Okay, so like that. So here we have two important transformations. That means by changing the variables Cartesians to two more. One is the cylindrical polar coordinates. So we are changing from Cartesian form to cylindrical polar coordinates. So that is the one transformation, and another transformation is Cartesian to spherical polar coordinates. So okay, here that Cartesian variables x, y, z, so be any point, say be the three variables in Cartesian form, so they are related to r phi z, so that is by the relation x is equal to capital R cos phi, y is equal to r sin phi, and z is same as z is equal to z. So here the coordinates r phi z are called the cylindrical polar coordinates of the point x, y, z. Okay, so let us see some relations between that. So here if you wanted to change dx dy dz to d, d phi dr and d theta. So here is d phi dz and dr. So in that time you need to find the Jacobian j. Jacobian j is equal to del of xyz by, so it is the del of r phi z, del of xyz by del of r phi z is here. We forgot to write that r. We write this okay, del of r phi z, so which is equal to del x by del r, del x by del phi, del x by del z. So it is the determinant of this del y by del r, del y by del phi, del y by del z by del r, del z by del phi, del z by del z. Correspondingly, you find partial differentiation of x with respect to r, x with respect to phi, x with respect to z. Similarly, y and z, and substitute that values here in the determinant and evaluate this. So if you evaluate this determinant, so finally we get j is equal to r. You just go and evaluate this one. Okay, so it gives that j is equal to r. Okay, that is Jacobian j is r, then dx dy dz can be written as dx dy dz is equal to, so that is r into dr, d phi and dz. Okay, so that same thing written here. It is a phi of r phi z is equal to r into dr d phi dz. So this triple integral dx dy dz are related like this. Here D is the region in which r phi z is vary, as x y z varies in the region R. So here we can write this r of phi or r phi z can are related like this. So it is a function of f is a function of x y z. What is x? X is r cos phi, y is r sin phi, and z is same as z. So r phi z. So they are related to. So it is that function f of x y z can be written like this. Okay. So let us see one more important transformation is spherical polar coordinates. In spherical polar coordinates, here that x, y, z are related to the another variables rho theta phi, so such that x is equal to rho into sin theta cos phi, y is equal to rho into sin theta sin phi, z is equal to rho into cos theta. Here the coordinates rho theta phi are called spherical polar coordinates of the point x, y, z. Okay, now so that Jacobian J can be found by using this del of x, y, z by del of rho theta phi. So that is del x by del rho, del x by del theta, del x by del phi. Similarly, del y by del rho, del y by del theta, del y by del phi, del z by del rho, del z by del theta, del z by del phi. Correspondingly, you take differentiation of x with respect to rho, with respect to theta, with respect to phi, and substituting in first row. Similarly, differentiate partially y with respect to rho, with respect to theta, with respect to phi, and substitute that in second row, and differentiating z partially with respect to rho, theta, phi, and substitute that in third row, and simplifying this. So just go and evaluate this. So then it gives that j is equal to rho square into sin theta. So determinant evaluate ಮಾಡ್ಕೊಂಡ್ರೆ ನಮಗೆ rho square sin theta ಬರುತ್ತೆ. Just go and evaluate this. So after finding this j, you can relate that x, y, z and rho theta phi such that so f of x, y, z into dx, dz, dy, dz over the triple integral r is equal to triple integration over d phi of rho theta phi, and it is dx, dy, dz is related like this rho square sin theta into d rho, d theta, d phi. So d is the region in which rho theta phi vary as x, y, z varies in region r. So rho theta phi is equal to function of x, y, z, or it is f of rho sin theta cos phi, comma rho sin theta sin phi, comma rho cos theta. Okay. Yes, let us see one problem based on these transformations. Evaluate the triple integration over r x, y, z into dx, dy, dz over the positive actant of the sphere x square plus y square plus z square is equal to a square. You know that x square plus y square plus z square is equal to a square is the sphere with center, origin and radius a. Okay. So now so we have to evaluate this by changing to cylindrical polar coordinates, that first one. Okay, that first transformation. To solve this, you take the sphere equation x square plus y square plus z square is equal to a square, and next step you write x, y, z in terms of r, phi and z. Okay, so that is x, y, z are related to r, phi, z like this in cylindrical polar coordinates. And all of you know that j values is equal to r, and correspondingly dx, dy, dz can be written as dx, dy, dz is equal to r into dr, d phi, dz. Okay, so now so here you see this if you take this x square plus y square, so then what happens? So here if you consider this x square plus y square, x square plus y square is equal to x square means that is r square cos square phi, x that is r square cos square phi plus y square means you see this is y square means r square sin square phi, r square sin square phi, which is equal to r square into cos square phi plus sin square phi. So then this becomes 1, so which is equal to r square. So in place of x square plus y square we can write r square. So here if you write this x square plus y square is r square, So then it is r square plus z square is equal to a square. So like that we have, by substituting using 2 in 1, we have r square plus z square is equal to a square. Okay, then to cover the positive actant means a part of the sphere in first actant. We are dividing that. So you see, when we are dividing that with the x, y, and z axis, so then we have total 8 parts. Among that, first actant means one by 8 part. So that means that is the first actant. In first actant, all x, y, z are positive. So to cover the positive actant of the sphere, here in first octant, like a quadrant, what you are talking in 2 dimensions, like that in 3 dimensions, so the first part is called the actant. Okay, so in first actant, that phi, that angle phi varies from 0 to pi by 2 degree, and that r, so r varies from 0 to a, because the radius of the sphere is a here, so it varies from 0 to a. And z varies from, if you write that z, that relation of z here, you see this, what happens if you write that z square, so then what it gives, z square is equal to a square minus r square. So z varies from 0 to root of a square minus r square. Z varies from 0 to root of a square minus r square. Correspondingly, if we take the limits 0 to pi by 2, 0 to a, 0 to root of a square minus r square into x, y, z. So that is r cos theta, r sin, r cos phi, r sin phi, and z is z only. So x, y, z ಇದೆಯಲ್ಲ, ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ, x ಅಂದರೆ r cos phi, y ಅಂದರೆ r sin phi, z ಅಂದರೆ z ನೇ, and dx dy dz can be written as, so r into dz dr d phi, r into dz dr d phi. Okay, okay, write all these values and simplifying this. Next is next step, you have to evaluate this integral. 0 to pi by 2, 0 to a, r into r is r cube sin phi cos phi. First integration is with respect to z. Integration of z is z square by 2 with the limit 0 to root of a square minus r square into dr d phi. Substitute the limits here. It is root of a square minus r square whole square by 2 minus, put z0 here, it is into dr d phi. Here this root and square cancels. This root and square cancels. So remaining is only a square minus r square here. And if you multiply this r cube with a square minus r square, so then what it gives? So it is r cube into a square is r cube a square minus r cube into r square is r to the power 5, and keep this 2 which is in denominator outside from the integrations, so then it is 1 by 2. So next integration is with respect to r. With respect to r integrate ಮಾಡಿದ್ರೆ ಇದು, so the integration of r cube is r to the power 4 by 4 minus integration of r to the 5 is r to the 6 by 6 with the limit 0 to a. So you apply the limits. Okay, so then what it gives? So it gives that a to the power 6 by 12 into d phi. So and lower limit is 0. So and keep this a to the 6 by 12 outside from the integration. So next integration is with respect to phi. You write this sin phi cos phi is sin 2 phi by 2, because you see sin 2 theta means sin 2 theta is equal to 2 sin theta cos theta. So sin theta cos theta can be written as sin 2 theta by 2. Similarly, you can write the sin phi cos phi as sin 2 phi by 2 into d phi with limit 0 to pi by 2. So integrate this, take this 2 outside, 24 2s are 24. Okay, keep this 2 as it is. Integration of sin 2 phi is minus cos 2 phi by 2 with limit 0 to pi by 2. Apply the limit here. A to the 6, 24 4s are, it is 96. minus cos 2 into pi by 2 minus of minus plus cos 0. So this is cos pi, because this 2 and 2 cancels, 2 cancels, this is cos pi value is minus 1, so it is minus of minus 1 plus 1, right? So minus of minus 1 plus 1 becomes 2, so it is a to the power 6 by 96 into minus of minus 1 plus 2, it is a to the 6 by 2 by 96. If you cancel the 2 and 96, it remaining is 48 in the denominator. So this is the value of that triple integral. Similarly, take one more example. Evaluate the volume of the region above the xy plane, bounded by the paraboloid. You know that parabola, if you take it's you rotate that parabola through axis, we get a solid structures, that is the paraboloid. Z is equal to x square plus y square, and its equation in 3 dimension is z is equal to x square plus y square. And the cylinder, equation of the cylinder is x square plus y square is equal to a square. It is a cylinder with radius a. Yes, in the cylindrical polar coordinates, we have to change these variables into cylindrical polar coordinates. So we have to change all x, y, z in terms of r, phi, z. Okay, so then what happens? So you see x square plus y square, you know that x square plus y square is equal to r square. So I already solved in last problem, x square plus y square is equal to, if we take r and so x and y values, so it gives that it is r square, and if you substitute x square plus y square is equal to r here, so it becomes r square is equal to a square. Now aವಾಗಲೇ ಸಾಲ್ವ್ ಮಾಡಿದ್ದೀನಿ. x square plus y square ಅಂತ ತಗೊಂಡ್ರೆ cylindrical polar coordinates values ಇದೆಯಲ್ಲ ಅದನ್ನು ತಗೊಂಡ್ರೆ, so what is that, x is equal to r cos phi, y is equal to r sin phi ಬರುತ್ತೆ. So x is equal to r cos phi, y is equal to r sin phi ತಗೊಂಡು ಅದನ್ನ ಸ್ಕ್ವೇರ್ ಮಾಡಿ ಆಡ್ ಮಾಡಿದ್ರೆ which gives that r square ಬರುತ್ತೆ. x square plus y square is equal to r square. So z is equal to r square ಬರುತ್ತೆ. If you substitute the same here, r square is equal to a square. Cancel that squares, then r is equal to a ಬರುತ್ತೆ. Okay. So then required volume is equal to evaluate the volume of the region above the xy plane. So it consists of 8 actants. Above xy plane we have 4 actants. Above xy plane we have 4 actants. So if you calculate that volume in first actant, so you take that into 4, it gives the volume above the xy plane. ಅಂದರೆ ನೀವು xy plane ಮೇಲೆ ತಗೊಂಡ್ರೆ, xy plane ಇಂದ ಮೇಲೆ ತಗೊಳ್ತೀವಿ ಅಂತ ಅಂದರೆ ವ್ಯಾಲ್ಯೂಮ್ನ xy plane ಮೇಲೆ ನಮಗೆ 4 ಆಕ್ಟೆಂಟ್ಸ್ ಸಿಗುತ್ತೆ. ಸೊ ಅದರಲ್ಲಿ ಒಟ್ಟು 8 ಆಕ್ಟೆಂಟ್ಸ್ ಅಲ್ಲಿ 4 ಆಕ್ಟೆಂಟ್ಸ್ xy plane ಮೇಲೆ ಇರುತ್ತೆ. ಸೊ 4 ಆಕ್ಟೆಂಟ್ಸ್ ಇರುತ್ತೆ ಅಂದರೆ ನಮ್ಗೆ 4 ಆಕ್ಟೆಂಟ್ಸ್ದು ನಮಗೆ ವ್ಯಾಲ್ಯೂಮ್ ಬೇಕು ಅಂತಂದರೆ ಒಂದು ಫಸ್ಟ್ ಆಕ್ಟೆಂಟ್ದು ವ್ಯಾಲ್ಯೂಮ್ ತಗೊಳ್ಳಿ, ಇಂಟು 4 ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ನಮಗೆ ಟೋಟಲ್ ವ್ಯಾಲ್ಯೂ ನಮಗೆ ಬೇಕಾಗಿರೋದು ಸಿಗುತ್ತೆ. ಸೊ ರಿಕ್ವೈರ್ಡ್ ವ್ಯಾಲ್ಯೂಮ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 4 ಇಂಟು ವ್ಯಾಲ್ಯೂಮ್ ಇನ್ ದ ಫಸ್ಟ್ ಆಕ್ಟೆಂಟ್. So what is the volume in the first actant? So how that z varies from 0 to r, and correspondingly you take the remaining values. So you see in first actant theta, that angle varies from 0 to pi by 2, phi varies from 0 to 90, so 0 to 90, and that radius vector, that r varies from 0 to a, because the radius of the cylinder is a here, so it varies from 0 to a, and correspondingly z varies from 0 to r square. So that into, so here we have to take 1 into dx dy dz, but if you convert dx dy dz is equal to what, r into dz dr d phi, so it becomes r into dz dr d phi. ಇಲ್ಲಿ ಬರೀ dx dy dz ವ್ಯಾಲ್ಯೂಮ್ ಬೇಕು ಅಂದಾಗ 1 ತಗೊಳ್ತೀವಿ, 1 into dx dy dz ತಗೊಳ್ತೀವಿ. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗಿದೆ, dx dy dz ನ ನೀವು ರಿಲೇಟ್ ಮಾಡಿ ಬರೆದ್ರೆ z r ಮತ್ತು phiಗೆ, it is r into dz dr d phi. So take that value. Now we have to integrate this with respect to z first, then with respect to r, and then with respect to phi. So just integrate with this with respect to z. So it is the integration with respect to z is z with limit 0 to r square. Substitute the limits. Limit substitute ಮಾಡಿದ್ರೆ it is r square minus 0. R square into r becomes r cube. So next integration is with respect to r. So integration of r cube is r to the 4 by 4 with limit 0 to a. Substitute that limits. It is a to the power 4 by 4 minus 0 is a to the power 4 by 4. We can cancel this 4 and 4. So ಬೇಕಂದ್ರೆ ಇದು 4 4 ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಬೋದು ನೀವು. You can cancel this 4 and 4. 4 cancel with 4. So remaining is only a to the power 4. So next integration with respect to 5. So integration of 5 is 5. So 0 to pi by 2. Apply the limit. Pi by 2 minus 0. So it becomes pi into a to the power 4 by 2. Pi into a to the power 4 by 2. That is the volume above the xy plane. Okay, so in next class I would like to discuss some more interesting problems on triple integrals by changing the variables. Okay, thank you.